Hello everyone. In this video we will focus on solving problems using quadratic models. Specifically, we're going to use the quadratic formula. Why? Because these are situations where we have quadratic equations that are not easily factorable. And this formula will allow us to determine the x-intercepts if y equals 0, or if y equals another value, it'll allow us to solve for the roots, the solutions to the quadratic formula, which we could also determine by factoring. So these are situations where the quadratic equation in standard form is not easily factorable, or it cannot be factored over a set of integers. There might be decimal values, rational values that take on the x-intercepts. So let's begin. In this first example, the population of a town is described with this equation, where P is the population in thousands, and T is the time in years, and T0 is the year 2000. So in the first question it asks, what will the population be in 2010? So 2010 minus 2000 is 10. So we're going to use t equals 10 to solve. So we begin with population equals 0.16 times 10 squared plus 7.2 times 10 plus 100. 0.16 times 10 squared. 10 squared is 100. So that's going to be 100 times 0.16 plus 7.2 times 10 is 72 plus 100. 0.16 times 100 is 16 plus 72 plus 100 is 172. And when we make the final addition, it becomes 188. So P equals 188 when T equals 10. And then we need to recall that the population's in thousands. So we would need to multiply this answer by 1,000. So recall populations in thousands. So we would times this answer by 1,000. So therefore the population in 2010 will be 188,000 people. So that's the prediction for 2010 if we were in the year 2000. Okay, so now example 2, part B of example 1, I mean, is what will the population reach when? When will the population reach 152,000? So we have a situation where the p-value is 152,000. We divide that by 1,000, so it's 152, because the equation is already expressed in thousands. And we set P to equal 152. So the left side is 152, and that will equal the right side, which is 1.16 t squared plus 7.2 t plus 100. So there's the start of the process here. We set the equation to 152. Now we're going to rearrange this into standard form. And that means we have to bring over the 152, so it's going to become negative. 152 minus 152 is 0 on the left side. And on the right side, it's 0.16 t squared plus 7.2 t plus 100 minus 152. And when we simplify that, we end up with standard form set to 0. 100 minus 152 is negative 52. So we have standard form of a quadratic equation, and we want to factor this and find what t values will equal 0, because we've set it to 0 now that we've brought over the 152 to the right side. So the 152 is reorganized on the right, which makes it negative, which puts us in standard form. And trying to solve for the roots here is not easy because we have decimal values. So in this example, the quadratic formula would be very helpful. So let's take this and let's open up a new page. Let me copy that. And let's open up a new page and let's continue with the quadratic formula. Okay, so we recognize we have a quadratic in standard form. We recognize it's not easily factorable over a set of integers given that we have decimal values. So we will use the strategy of the quadratic formula. What is the quadratic formula? Well, it's listed above. We take on values of x. In this case, it will be values of t. And how do we find the roots? Well, negative b plus or minus the square root of b squared minus 4ac all divided by 2a will produce the roots. If y equals 0, this will produce the zeros. In this case, y equals 152. When will the population of the town reach 152,000? We divided 152,000 by 1,000 and we set the population to 152. And then we rearranged the equation in standard form, and by bringing over the 152, it made the left side 0. So we have standard form on the right equaling 0 on the left. And when you compute the quadratic formula for the a, b, and c values of this standard form, it will produce the solutions. So let's continue. So we need to identify a, b, and c. So a is 0.16, b is positive 7.2, and c is negative 52. So we take those values and we substitute them into the quadratic formula. So x equals negative b. I'm going to leave brackets for now, and then I'll show you how they get subbed in. The square root of b squared minus 4 times a times c all over 2a. So b is 7.2. Those are the positions where we'll substitute in the b value. A is 0.16. Those are the positions where we will sub in a. I forgot one bracket here. Let's add it on. And a is 0.16. And c is negative 52. Next, we're going to follow BEDMAS and calculate these values. So negative bracket 7.2 becomes negative 7.2. The denominator is 2 times 0.16. So that's going to become 0.32. The plus or minus we can't deal with yet. The square root we can't deal with yet. So next we're gonna calculate the 7.2 squared. 7.2 squared. So that's 51.84. And then we need to calculate 4 times 0.16 times negative 52, and that's going to equal negative 33.28. Okay, so we dealt with exponents, we dealt with multiplication. Now we could deal with the subtraction. So the negative 7.2 we can't deal with yet. The division of 0.32 we can't deal with yet. The adding and subtracting of the square root we can't deal with yet. But we could deal with the inside of the square root. We could deal with the subtraction. And 51.84, subtracting a negative is like adding. So 51.84 minus negative 33.28 becomes 51.84 plus 33.28, and that will equal 85.12. Now the answers are going to become a little bit more complicated because we're going to have a lot of decimals, and we don't want to round any decimals off, so we need to keep the exact values. So we're going to square root 85.12, and that's going to lead to a long decimal, which we're going to keep on our screen, and we're going to separate the addition and the subtraction. So I'll write it as a square root, 7.2 plus the square root of 85.12 divided by 0.32, and we have negative 7.2 minus the square root of 85.12 divided by 0.32. So on the left, the addition we'll do first. So the square root of 85.12 becomes a long decimal, 9.2260500076. I'm just going to make a note of it here, but I'm going to leave it on my screen. So 9.2260500076, and it continues. It just stops because our screen ends on our calculator. So let's leave that on our calculator. Let's add that to negative 7.2, and then let's divide by 0.32, and that equals 6.3314, and it continues. And the other value that x could take on, let's go back, let's start again. Let's clear our screen. So 85.12, take the square root of that, and we have 9.22 back on our screen. And let's subtract that from negative 7.2. So negative 7.2 minus, hold on, let me clear my screen and start all over. So negative 7.2 minus the square root of 85.12, and that's going to equal negative 16.426, etc. And we divide that by 0.32, and that equals negative 51.33, etc. And let's round off. Let's now round, since we have no further calculations to do. Let's now round these off to approximately 6.3 and approximately negative 51.3. So let's pause for a moment and consider what we have. The standard form equation before we started using the quadratic formula was 0.16 t squared. So this equation here, 0.16 t squared plus 7.2 plus negative 52. The a value is positive, so this parabola is going to be opening upward. So at a certain point, and this is 152 on the y-axis. So this point is 152 on the y-axis. So at negative 51, we're up at 152 at 0.3, and at 6.3, we're up at 152 as well. So the y-axis is somewhere over here, and you could see there's 2 points in the parabola when the population is at 152,000. Like, the theoretical image of a parabola, of this quadratic equation, it is a parabola. And because it's positive, we're going to have a minimum value. So it's going to go down and up. So this negative aspect is a possibility. And in the context of the question, t equals 0 is in reference to the year 2000. So if t is positive 6.3, right, I used x because the quadratic formula we had an x value, but that's referring to t. That t could be 6.3, and t could be negative 51.3. And if that's the case, then p will equal 152. That was the whole point of the quadratic formula, for solving for roots that are not over integer values. It's not part of the set of integers. These roots are part of the decimal family, rational numbers. So either we're going to add this to the year 2000. So approximately in the year 2000 plus 6.3, which is 2006, the population will reach 152,000 because we're moving forward in positive time. But technically we could consider negative 51, and we would take the year 2000 and minus 51.3, which puts us approximately at 1948.7 approximately. And in 1948.7 would be the other point on the parabola that where the population equals 152,000. Given that the parabola is a positive parabola, and this potentially could be the negative 51.3 point, and this potentially could be the 6.3 point, and we know that parabolas are symmetrical. So technically, there's 2 points in time when the population is 152,000. If we consider the negative time frame going back in time, it would be the year would be approximately 1948. So, do we consider both? Technically, yes, but we're moving forward with positive time. So, in terms of positive time moving forward, we can expect the population to reach 152,000 in the year 2006. And we did this by solving the quadratic and not by factoring. We did this by using the quadratic formula, which takes us straight to our solutions at this point, when those solutions are not part of the set of integers. So that concludes this video on solving quadratic models using the quadratic formula when the solutions are not part of the set of integers. Thank you for watching this video. Please leave your comments and questions below in the comments section. If you like this video and want to see more of them and want to be updated when they're posted, please subscribe to my channel and like the video. Thank you and have a great day. You guys are awesome.